The overall goal of the following experiment is to measure the flow of a liquid metal electrode of the sort used for energy storage in liquid metal batteries. This is achieved by bringing the liquid metal to a steady temperature and putting it in contact with an ultrasound probe. As a second step, sound speed is measured, which is necessary for subsequent velocity measurements. Next, ultrasound probes are used in order to measure flow while varying the electrical current flowing through the electrode. The results show that increased current drives flow, which would improve battery performance.
The main advantage of ultrasound over other methods like hot wires or thermistor pairs is that those make a measurement at a point, whereas ultrasound makes a measurement along an entire line through a fluid. That gives us much more information with which we can glean more insight about the mixing and mass transport in energy systems like liquid metal batteries.
Though this method can provide insight to liquid metal batteries, it can also be applied to other technologies that depend on fluid flow, such as flow batteries and fuel cells.
First, load the ultrasound transducer, lead bismuth, stir stick, and thermocouples into a glove box, following the instructions of the glove box manufacturer to minimize ingress in oxygen and moisture. After tuning the PID controller, use the furnace to melt at least 400 grams of lead bismuth. Insert an ultrasound transducer into the sound speed measurement device and tighten the swage connection to prevent leaks.